In this tutorial, we'll practice factoring a polynomial by using a GCF, a greatest common factor. So by the end of this lesson, you should be able to factor an algebraic expression using a GCF by doing the following three things correctly: determining the GCF for the coefficients, determining the GCF for the variables, and writing the GCF and that quotient as factors of each other. So let's take a look at what it really means to be factors. So factors are numbers that are multiplied together and they give you a product. And so I'm going to use this simple problem here just to get used to the word factor. So if you're given the product, which for us is 15, then you can find at least one of the possible factors by using your multiples, right? Your multiplication facts. So if I'm thinking of two numbers that multiply to 15 and I have two different area models here to show that it looks like the length and the width of my first rectangle would probably be numbers that are closer in dimension than the length and the width of my second area here. So if I were to think of just some integer factors of 15 here, I'm thinking that this one might represent 3 times 5. And the only other integer factors I can think of for 15 are 1 and 15. So that would make sense here. Now in some cases, the factors might not always be integers, right? So if I told you one of the factors was 3, then you can use your division property of equality here to show that the missing factor must be whatever 15 divided by 3 is. And for us, that's 5. And the same is true for this missing factor. If I were to divide both sides by the factor I already have here, which is 2, then I know that the missing factor would be 7.5, right? So you can have factors that are integers, right, this whole number 5, or rational numbers like 7.5. And what we're going to practice today is finding this number using a GCF, a greatest common factor, for the coefficients or the variables that were given. So I'm going to give you a polynomial expression that might look something like this. And I'm going to ask you to work your way backwards to that. So to factor a polynomial means to do the opposite of distributing. If I were to ask you this question here, you would simply multiply 7 times a, and you would add that to the product of 7 times 4. Right? So that's what this is written out the long way. And 7a is 7 times a is 7a, 7 times 4 is 28. So if you have the polynomial 7a plus 28, it has a factor of 7 times the quantity a plus 4. That is a factorization. That is another way of writing this polynomial as a multiplication problem. That's what factors are, right? Factors are items that multiply together that give you a product. So if my product is 7a plus 28, then my factorization is 7 times a plus 4. So let's take a look at how we're going to do this. So step 1 is we need to find the GCF of the coefficients. This is something you'll be familiar with. You've been doing it since the younger elementary grades. And the second is we're going to find the GCF of the variables. So this is somewhat new for you. And the trick is that the GCF, the greatest common factor of the variables, which is similar to the coefficients, is actually the smallest amount that they all share, right? So for us, when we look at our variables, we're going to be looking for the smallest power, and that will tell us what our GCF is, if they share that variable. Step 3 will be dividing each term in our polynomial by the GCF that we thought up ourselves, and then we're going to set up our two answers in factor form, right, as a product. So let's take a look at our first example. If you have a copy of the notes, then this is on the notes on the left-hand side. So 3a squared plus 6a plus 15. So I'm going to look first only at the coefficients or constants in this case. 3, 6, and 15. Now you can never have a GCF that is higher than your lowest value. It can never be higher than your lowest value. So since my lowest value is 3, my GCF has to be 3 or lower. So 3, 6, and 15 can all be divided evenly by the number 3. Now, the first term has an a, the second term has an a, but the third term does not. So they do not all share the same variable, so there is no variable GCF. So the GCF for this entire polynomial is just the number 3. I'm going to divide every single term by my GCF. And when I do that, I take my GCF and I write that first. 3 is what I divided every term by, and this is what happened after I divided, right? So 3 divided by 3 is 1, and the a squared remains. 6 divided by 3 is 2, and the a remains. And 15 divided by 3 is 5. This is called factored form. If you were to distribute your two factors, you will get your original polynomial. 3 times a squared, 3a squared. 3 times 2a, 6a. 3 times 5, 15. Here's the second example that does include a variable. So always look first at your coefficients or constants, and the smallest one is 4. So the highest my GCF can be is 4. And 4 does evenly divide into each of these terms, so my GCF numeral will be 4. And then when I look at all of the variables, they all in fact have the letter m. So if you share the letter m, find the lowest power. 3, 2, invisible 1. So this is the lowest power, so that becomes my GCF variable. Divide all 3 terms by that GCF. Now this time our GCF has a coefficient and a variable. When I divide each of these terms separately, the results will be written inside the parentheses. 8 divided by 4 is 2. M to the third power divided by m to the first power means you keep the base the same and you subtract the powers. That's how we got a 2 here. 12 divided by 4 is 3. M squared divided by m to the first is m to the first. And this one can be a little tricky. 4m divided by 4m does cancel out, but it does not make a 0. It makes a whole, so you have to put that 1 in your answer. Don't forget, if you distribute your solution, it should always come back to be your original polynomial. All right, let's take a look at a couple more examples before you try it on your own. So I'm going to look at my 3 front numbers here, and the smallest one is 5, so I can't pick a GCF higher than that. So my GCF is going to be 5, because 5 can divide evenly into 20 and 15. They all share the letter x, and the smallest variable power is 3, so 5x cubed will be my GCF. That's my GCF. So what I'm going to do here is I'm going to divide every single term by that GCF. I'm going to divide every single term by 5x cubed. And as I'm writing it, I immediately write it on my answer line. If you used it to divide, you must write it down as one of your factors. 5 divided by 5 is 1. X to the 6th divided by x to the 3rd is x cubed. Negative or minus 20 divided by 5 is minus 4, x to the 1st, and the final term will be 3. The x to the 3rd divided by the x to the 3rd reduces to 1 whole, but I don't need to write it since I have a 3 already. Again, I'm going to look at my coefficients first, and 5 is the lowest number, but it is a factor for both of these, so I am going to divide by 5. And when I look at their variables, they do not share the same variable. So the only thing I can divide by is 5. And I write that in my answer first. Once I finish dividing, I can even leave this one off here. Right? We can just write m plus 2n. All right, one more. Coefficient of 3, coefficient of 6, coefficient of 1. Well, 1 is my lowest coefficient, And dividing by 1 doesn't do anything, so I'm not even going to bother writing it. They all have x's, and this is the smallest x, so that's the most I can divide by. They don't share any other variables in common. So my factorization will be x times 3xy cubed plus 6y squared, and be careful here, plus 1. Now try these two in your notes. Pause the video and come back when you're ready to check your answer. How did you do? All right, let's try a couple more. On the other side of your notes, there are 8 more examples. You can pause the video now, try all 8 of them, or try 4, the first 4 here, and check your answers, and then try the second set of 4. But I'm going to solve them for you now. Two more. Now in this example, my lowest variable power for m was 2. So I am able to divide each of the terms by 2 m's. And what remains after I divide by that monomial is 6m plus 7n. Last one for this section. This one's a little bit tricky. 4, 8, and 1. So 1 is my lowest coefficient, so that is my GCF. I'm not going to write it because dividing by 1 doesn't do anything. But they do all share the letter x, and that's it. The third term does not have a y. So x is my GCF. And be careful here, x divided by x is 1 whole. Alright, take a look at these last 4 and try them on your own. Pause the video. I'm going to solve them for you now. This has a GCF of only a, and the product here is a times the quantity ab plus 3. Number 8 only has the letter x as a common variable. 1 plus xy plus x squared y squared. Now the second polynomial isn't in descending order, but neither was our original, so I'm going to leave it that way. Number 9, the GCF here can't be higher than 4, so 4 is a factor of all 3. And the lowest variable power for m is m to the first. And they do not all share the letter n. See, he's missing that. So n cannot be a factor. So 4m is the factor here that we're dividing by. And mn squared plus 4n plus 3 is our other factor. Don't forget, you can always check your work by distributing out your solution. Number 10. The only GCF here is x. That results in a 5xy squared plus 10y plus 1. Alright, there's only one other thing that can happen when you have a polynomial and they ask you to factor it out using a GCF. And that is that sometimes your leading coefficient is negative. And you'll come to find out later on that sometimes when you are factoring, something is a negative and you wish it wasn't. And you can always change a sign by dividing by something that's negative. So if your leading coefficient is negative, you should always factor out some negative value, whether it's a negative GCF of the coefficients or just a negative one in general. So when I look at my coefficients here, I know that the highest it can be for my GCF is 2. But since my leading coefficient is negative, I'm going to divide by a negative here. Looks like they all have an x value. So negative 2x will be my first factor. And inside here, I'm going to get x squared. A negative divided by a negative is a positive. In the middle here, I'm going to get a negative 2x. And at the end, I'm going to get a positive 3. So when you divide by a negative, don't forget to always double check your signs. Let's take a look at two more. So here, I'm going to divide by 5. And since my leading coefficient is negative, I'm going to divide by a negative 5. And they all have the letter A in common. And when I divide by my monomial of negative 5a, I'm going to get 1a squared b squared plus 2ab plus 9. All right, let's take a look at the very last one here. I don't see much that they have in common, but it does say that if you have a negative leading coefficient, you should factor out a negative value. Now the problem is if they don't have a common factor and they don't have any common variables, then you simply choose negative 1 as your factor. Now you can actually write the digit 1 when you're factoring, or you can leave the 1 invisible and just write the negative sign. But the result when dividing by a negative 1 is that all the items will remain the same, all the terms will remain the same, but all of their signs will change. So now I have a negative 3x and a positive 5. Again, the 1 here is optional. Alright, I uploaded some practice problems to the Google Classroom. You can give those a try now and pause the video. Or you can leave this screen up here and check your answers as you go. Either way, this completes our lesson on factoring using a GCF. I hope it was helpful and that you learned how to do the technique.